Hi guys, let's start a new exercise in this chapter, circles. But before we start, let's quickly revise the four theorems that we did in the previous video. So the first one, it said in case you have a line from the center of the circle which bisects a chord, then this line is perpendicular to the chord. So if a line from center to a chord bisects it, then it is perpendicular to chord. So this was the first one. If a line from a center which bisects the chord, then the line is perpendicular. The second one was converse of which means if line perpendicular to chord, then it bisects, which means we are talking about a line perpendicular to chord starting from the center. Perfect. Next one was equal chords are equidistant from the center. So equal chords are equidistant from center. And the next one, which is the reverse of this or the converse of this, was equidistant chords are equal. Perfect. So our first exercise was basically focused on these two. The second exercise that we have here, 17b, will focus on all four. So let's look at some questions and let's move on. So question number 2. Question number 2 says a straight line is drawn cutting two equal circles and passing through the midpoint M of the line joining O and O dash. Okay, so what is given is, let's figure out. So OM is given equal to O dash M, since M is midpoint. So this part is given. Two equal circles. So equal circles would mean radius of circle 1 is equal to radius of circle 2. So radii of both circles are equal. In this case, if I look at OA, what it basically means is OA is equal to O dash C. O dash C. So OA and O dash C are equal. Next, prove that the chords AB and CD are equal. So what we need to prove is these two chords are equal. How do I prove it? Let's draw some perpendicular, because I remember the first property, which is perpendicular from center of a circle to a chord bisects it. So let's draw a perpendicular from O onto AB and from O dash onto CD. So let this be point P and let this be point Q. So this is P, this is Q. Let's just write this down. Draw OP perpendicular to AB and O dash Q perpendicular to CD. Since this is perpendicular, which means it will bisect the chord. So let's just write that down. Since OP is perpendicular to AB, therefore OP bisects AB. What I get is AP is equal to BP is equal to half of AB. And next part, we get since O dash Q is perpendicular to CD, therefore O dash Q bisects CD. What this gives me is CQ is equal to QD is equal to half of CD. Done. Now let's see if we can prove these two triangles congruent. If I can prove these two triangles congruent, then I should be able to get some part equal. Let's see. So if I look at these two triangles, I have one angle equal vertically opposite. I have a 90-degree equal. Anything else that I have? Yes, OM and O dash M are equal. So I have a angle side. Let's just write this down. So in triangle OPM and triangle O dash QM. O dash QM. What do we have? We have point number 8, which says angle OPM is equal to angle O dash QM is equal to 90 degree. Reason, this is by construction, we constructed it as 90 degree. By construction, sorry, let me just rewrite it, by construction. Next, point number 9, angle PMO is equal to angle QMO dash. Reason, vertically opposite angles are equal. And point number 10 is OM is equal to O dash M. This is from 1. So by angle side, these two triangles are similar. Therefore, by angle side test, triangle OPM is congruent, not similar, congruent. Sorry, O dash is congruent to triangle O dash QM. How does this help us? What we get is, therefore, OP is equal to O dash Q. This is CP, CT, C. Now, what does this mean? It means that in case these two chords are equidistant, which means the chords are equal. Now, let's just write that down. Since AB and CD are equidistant from the center of two equal circles, therefore the chords are equal. In this case, therefore AB is equal to CD. Hence proved. Good, interesting question. Let's look at the next one. The next one that we solve is question number 3. Let's look at question number 3. It says M and N are midpoints of two equal chords. Okay, so let's just write what is given. AB is equal to CD. These are equal chords. And M and N are midpoints, which means half of AB should be equal to half of CD, and half of AB is AM, which is also equal to MB, which is also equal to half of AB, which is equal to half of CD, which is equal to CN, which is equal to DN. Good, so all these sides are equal in length. Perfect. We need to prove angle BMN. So where is angle BMN? Okay, so if I join this line, I get angle BMN is equal to angle DNM. So I need to prove these two angles are equal, and angle AMN. Okay, so since this is a straight line, if this angle is equal, then this obviously angle is equal. These are supplementary angles. Good. So let's join these two. This is the center. Is this the center? Yes, this is the center, and this is marked O. So let's join O with M, and let's join O with N and see what do we get. Since this is the midpoint of the chord and I'm joining this to the center, the angle it makes is 90 degree. Similarly, N is the midpoint, the angle it makes is 90 degree. So let's just write that down. Number 4, join OM and ON. 5. Since M and N are midpoints, therefore angle OMA is equal to angle OMB is equal to angle ONC is equal to angle OND is equal to 90 degree. Perfect. So line joining the midpoint of a chord to the center makes an angle of 90 degree. Good. And next part would be OM is also equal to ON. Why? Since AB and CD are equal chords, this is given in the question, therefore they are equidistant from the center. Done. So we've got this now. Basic things here. We need to figure out the angle. Okay, so triangle OMN is isosceles because we just said is isosceles because we had OM equal to ON, which means since OM is equal to ON, which means what we get is angle angle OMN is equal to angle ONM. Let's take this to be X. So this small angle here is X and this small angle here is X. This big angle is 90, this big angle is 90. So let's just subtract and see what do we get. Number 9. So angle BMN is equal to 90 degree minus X, and number 10 is angle DNN is equal to 90 degree minus X. Since angle BMN is equal to 90 degree, BMO, not M, BMO is equal to 90 degree, and since angle DNO is equal to 90 degree. Where did we get this? This is from 5. Good. So from 9 and 10 we get angle BMN is equal to angle DNN. That's what they wanted us to prove. Done. Let's look at the next part of it. Next part is angle AMN. So number 12, angle AMN is equal to 90 degree plus X. Now since angle AMO is equal to 90 degree. Similarly, angle CNM is equal to 90 degree plus X. Since angle CNO is 90 degree. We got this from 5. So from 12 and 13 we get angle AMN is equal to angle CNM. Hence proved. Done. So this finishes this question. Let's look at the next one. The next one that we do is question number 4. Let's read the question. Question 4 says, in the following figure, P and Q are points of intersection of two circles O and with the center O and O dash. If straight line APB is a straight line and CQD are parallel to OO dash, okay, prove that OO dash is equal to half of AB and that AB is equal to CD. So let's just join, draw a perpendicular from O onto AB and from O dash onto AB. So since we are drawing a perpendicular, which means it will bisect the chord, which means let this point be R and let this point be S. So let's just write this down. What we did, draw OR perpendicular to AP, and number 2, draw O dash S perpendicular to BP, which means since OR and O dash S are perpendicular to the chords, what we get is AR is equal to RP is equal to half of AP, and what we get is PS is equal to SB is equal to half of PB. Yes, half of PB. So this is fine. Now we have these two lines parallel. So what should be the measure of sum of angle R and angle O here? Well, yes, the sum of angle should be 180 degree because these are co-interior angles, which means this is also 90, which means this angle is obviously 90 because this is a quadrilateral. The sum of all angles should be equal to 360 degree. So let's just write that down. Since AB is parallel to O dash, therefore angle ORS plus angle ROO dash should be equal to 180 degree. This is sum of co-interior angle. This is point number 6 for us, which means angle ORS is 90 degree. Therefore, angle ROO dash is equal to 180 degree minus 90 degree is equal to 90 degree. Which means therefore quadrilateral OO dash SR is a rectangle. All base angles or vertex angles are 90 degree, which means it is a rectangle. What this means is, therefore, OR is equal to O dash S and OO dash is equal to RS. This is opposite sides of a rectangle are equal. So we've got the opposite sides of a rectangle are equal. Let's see if we can get something from here. So number 11, we have we need to prove OO dash, right? So OO dash is equal to RS, which is equal to RP plus SP. Yes, it is equal to RP plus SP. But RP here is equal to half of AP and SP is equal to half of BP. This is from 4 and 5. Here we said RP is equal to half of AP and SP is equal to half of BP. What it gets, so in the right hand side I have half common. I take AP plus BP, and AP plus BP is nothing but AB. So therefore OO dash is equal to half of AB. That's what they wanted us to prove, hence proved. Next, the next part of the question says we need to prove that AB is equal to CD. So we'll have to do the same thing, but this time on the opposite side. So again, I will draw a perpendicular here. I'll draw a perpendicular here. Let's call this X. Let's call this Y. This angle obviously is 90. If this is 90, this is 90. So let's just write that. Draw OX perpendicular to CQ and O dash Y perpendicular to QD. What this means is, therefore, quadrilateral OO dash YX is a rectangle. What we also get is CX is equal to XQ is equal to half of CQ, and we get QY is equal to YD is equal to half of QD. So we will be able to prove OO dash is equal to XY, which is equal to XQ plus YQ, which is equal to half of CQ plus half of QD, which is nothing but half of CD. So we get OO dash is equal to half of CD. So OO dash is equal to half of AB and OO dash is equal to half of CD. Let me just erase the first part of the question that I wrote here so that I have some space to solve the last part of the question. So from 14 and 20, what we get is OO dash is equal to half of AB, which is equal to half of CD. Now if I compare these two, half and half gets cancelled, which means therefore AB is equal to CD. That finishes this question for me. Before I go, let me mark some homework questions for you. Homework question for you would be question number 1. That's about it. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.